Hello, it's Mr. Tuxford here. We are going to go through the step-by-step guide that I've written for you to get up to merit for your Level 3 Physics Investigation Assessment. So this standard is very systematic in that you are doing an investigation, so following the scientific method, being careful and accurate with your measurements, averages, plotting your graphs, and then comparing to the theoretical equation. So this video will be quite long, but it's worth rewatching a few times, and I recommend while you're watching it, taking notes as well as finishing off one of your own practice investigations at the tricky steps. So the task we're going to look at today is the simple pendulum, right? It is a simple practical, so it won't get in the way of our analysis. We are given the theoretical equation, right? Time period equals 2 pi times the square root of L divided by G, or you can also write that as 2 pi divided by square root of G times the square root of L. So you might have seen that form before, which will be helpful when we compare the gradient, right? So the gradient's at the front, and then the transformed independent variable is like our x value. So step 1, read the task thoroughly. Done? Yeah, well, I've already read it, but you should read it in a bit more detail. Brief method, the setup, being careful that a few points like to the center of mass of the bob, so there's some uncertainty in that length measurement, making sure you understand the background equation. I can see time period is proportional to the square root of length, so we're looking at a square root relationship, which is good to identify early. Great. Part 2, identify the variables. So looking at this, we are given time period of oscillation and length, right? Those are our variables. So we are changing length, independent variable. We are measuring time period, dependent variable. So let's just write a quick scaffold. So we've read the task, now we've got our variables. So we have independent, dependent, and of course our controlled variables. Our independent variable, the thing we are changing, which was the length of the string in meters, measured from the fixed point to the center of mass of the bob. Great. And we need at least 5 different measurements. We will use 0.2 meters, 0.3, I think, wait, what did I choose? No, 0.2, these ones right here. There we go, paste like that. 1.0 meters, cool. And how you will come to think of these, how you will decide what values to use is by trying it out, right? So you set up your pendulum, you try a very small length, like, I don't know, 5 centimeters. You'll probably find that that's way too quick to measure, unless you use a slow motion camera. And then you'll find that anything maybe above 1 meter, it's just hard to get going. You can't use the floor as an excuse not to go longer, right? Because you can just take it up some stairs. But yeah, at least 5 values over a decent range. So we've identified the independent variable. The dependent variable is what we are measuring, which is the time period of the oscillation, measured, how do we measure it? With a stopwatch in seconds. Being a bit specific here, we could say we will measure 10 periods and then divide by 10 for 1 period. Right, that's already jumping ahead a little bit to the accuracy improving techniques. Stopwatch is one word. There we go. Our controlled variables. Now these are the variables that are significant, right? So we can't control weather. Looking at our equation, we can't really control G. I mean, unless we did it on another planet, which, implying we're not. So what else would be significant? What are some things that might change the length that we didn't think about. So, for example, the bob, the thing on the end, if its center of mass changed, then the length would change. So we need to keep the bob the same. Similarly, how we attach it at the top, if that changes, so the fixed point moves up or down, that is actually also changing the length. So those would be the two most significant controlled variables. So we'd have controlled variables, the bob, keep the bob the same to ensure that its center of mass doesn't change. The fixed point, keep the fixed point the same to ensure that the length doesn't indirectly change. Cool. So let's just double check. Have we identified the dependent variable? Yes. Significant controlled variables? Yes. Explained how you will change the independent length? We've explained the range of values. Maybe we could add, we will make these changes by shifting the string through a split quark and measuring the length each time. From, we already mentioned how we're measuring it. Great. So that's how we will change our independent variable, how we will measure with a stopwatch in seconds, specifically 10 periods, and how we will control these variables, keeping the bob and fixed point the same throughout each trial. Now, as I've written here, this wouldn't quite be a merit, right? Surprise. We do need a bit more details. So that could come in the discussion. But for now, I'll just keep it brief so we can move on. Yeah. So next up, writing a brief but specific method. Gather equipment, set up equipment, see diagram above, right, the one in the task. Set the length to 0.2 meters by measuring from the center of mass of the bob to the fixed point. Fix in place with the split cork. Bring the bob, I don't know, let's say 20 degrees from equilibrium, and release. Start timing once it reaches the first maximum, and stop timing after 10 full periods. Divide the time by 10 for a single period. Repeat steps 3 to 6 for the other lengths. No. Repeat steps 3 to 6 2 more times. Right, 3 trials and average. And then repeat steps 3 to 7 for the other lengths. Right, so we have a very basic but specific method explaining how we're getting the equipment, how we're setting up, just with reference to the diagram, but then being a bit specific in how we measure the length and how we measure the time, right? Because those are the independent and dependent variables we care about. Right, so write a brief but specific method. Excellent. List and explain the relevant accuracy improving techniques. Accuracy techniques. So we've already touched on a few in how we've described the variables, controlled variables, and method, but let's just make it specific. So the techniques you should be considering, so bullet point that. These 5, right? There are more. You don't need all 5. but just what are the significant ones. So for us, definitely repeating and averaging. So just describe that. So we will do 3 trials and average the period. Why do we do this? This is to reduce the effect of outliers and random errors. Yep. Now you can go into a bit more detail here, of course. Multiple measurements. This is probably the most important one for this experiment, and that is where you measured 10 periods and then divided by 10. So we will measure 10 periods and then divide by 10 for 1 period. Now why do we do this? This is to reduce the effect of human reaction time. Because if you think about measuring 1 period, it's very quick, like less than a second. And so your reaction time, if it's 0.3 seconds, that's like a third of the measurement, or potentially a third of the measurement. So multiple measurements to reduce the effect of human reaction time. Again, go into a bit more detail than I'm writing here. This is just to get you started. Precision of the measuring equipment. We used millimeter precision rulers and stopwatches that went to centiseconds. A little bit funny, you might not have seen that before, but yeah, it is what it is. And now, of course, if we want more precise equipment, we could use a slow motion camera. For the length, we could use like laser rulers, we could have some like more advanced setup, but this is as precise as we went in class. Parallax error, we will carefully measure the length of the string by placing the ruler parallel to the string and reading the measurement perpendicular to the ruler to avoid parallax error. Right, so parallax error is when you take the measurement and you're looking at it from a different angle to give you an incorrect measurement. So of course that's something easy that we can reduce. And zero error, we will ensure the stopwatch starts from 0 seconds, obviously, and that thinking of the ruler, right, some rulers, the very edge is 0, some of them come in a little bit, so we just need to keep that in mind. So we want to ensure the stopwatch starts from, and that we count for the 0 error on the ruler. Awesome. So we have listed, well in this case I've listed 5. I would say aim for 3. In this particular experiment, repeat and average, multiple measurements, and parallax error would be the most significant. Yep. And again, I've written it to like a high achieved level, just taking it a little bit further and linking it back to your variables would give merit for the accuracy improving techniques. Whew. Alright, how are we doing for time? Already been 13 minutes. Wow. Look at us go. So now's a good time to just reflect what we've done so far. We have read the task thoroughly. We have identified a square root relationship between time period and the square root of length. We have listed out the independent variable, the dependent variable, the significant controlled variables. Right, we didn't say we're keeping gravity the same or we're doing it inside, because yeah, those aren't as significant. We've outlined a brief but specific method, and we've explained the accuracy techniques and why we are using them. Cool. So let's move on. I might make this into a few parts actually, so I'm going to stop this video and then we'll resume with making a raw data table.